Hi, I'm Tyler LaBonte, a PhD student at Georgia Tech. On behalf of my co-authors Yale Wang, Vibhav, Vineet, and Neel Joshi, I will present the paper Scaling Novel Object Detection with Weakly Supervised Detection Transformers, a collaboration between Microsoft Research, Meta AI Fair, and Georgia Tech, presented at WACV 2023. Object detection is a fundamental task in computer vision where the availability of datasets with fine-grained bounding box annotations have enabled neural networks to achieve remarkable performance. However, the annotation process for object detection can be expensive and time-consuming. To this end, we consider Weakly Supervised Object Detection, WSOD, which aims to learn object detectors using only image-level class annotations. In particular, given a model pre-trained on a box-annotated source dataset, we would like to fine-tune the model on a target dataset of novel objects using only image-level class annotations. Previous WSOD models often generate object proposals using a heuristic such as selective search, then use multiple instance learning, MIL, to recover high-likelihood proposals. However, current approaches are not scalable, as they require multiple rounds of computationally intensive refinement, and they are typically optimized for datasets with as few as 60 pre-training classes and 20 novel classes. This makes today's WSOD models impractical for industry applications. To address this, we propose the Weakly Supervised Detection Transformer, WSDETR, which integrates DETR with an MIL architecture. Our model takes advantage of the pre-trained transformer to scale to thousands of classes in a single efficient fine-tuning procedure. Our WSDETR is a hybrid which combines the comprehensive proposal generation of the two-stage RCNN framework with the scalability and simplicity of transformers. We first pre-train a class-agnostic DETR on the source dataset with bounding boxes only to serve as the proposal generator. Then, for WSOD training, we initialize a model with a frozen box predictor from a class-aware DETR pre-trained on detection annotations including classes. These features are fine-tuned and used to learn an MIL classifier. Instead of region of interest pooling, we utilize the DETR's object queries, so the transformer decoder produces classification predictions which correspond to object proposals. We evaluate our method on the FSOD dataset, which has 4 times more source classes and 2 times more novel classes than the previous largest datasets used for WSOD. It is a difficult dataset where the source and target classes are maximally separated with respect to a semantic hierarchy to maximize novelty. Our WSDETR outperforms the state-of-the-art method of Zhang et al., whose class-agnostic transfer setting is closely related to ours. We also evaluate our method on the iNaturalist dataset. With 2,854 subclasses, this dataset has 5 times more classes than OpenImages, and it is a realistic dataset for industry-scale fine-grained novel object detection. Our method scales to this massive setting and achieves state-of-the-art performance. We also show that the objectness regularization of Zhang et al., which uses pre-trained object knowledge to improve weakly supervised detection, overfits to distinctive classification features. We propose a new method for estimating the joint object and class probability of a detection, which easily rectifies this error. Finally, we perform the first large-scale rigorous study of pre-training scaling for WSOD. By comparing the model performance using a certain proportion of pre-training images versus the same proportion of classes, we find that class quantity is more important than image quantity for WSOD. This confirms the hypothesis of Weachlings et al. And suggests that to maximize WSOD performance, we should construct new pre-training datasets with thousands of classes and few images per class.